Hi everyone, I just want to go through some statistical tests that you're going to need to use for your SL525, SL545, applied exercise physiology lab practicals. The specific test I'm going to run through today is a repeated measures ANOVA, which I'm sure you remember from your data analysis module last year. But if you just need a little bit of a reminder on how to actually go through inputting all the data and running the tests, then hopefully we'll go through all that for you now. Just to remind you what the data is, this is week 2's data. So we did an isometric hand grip exercise during which we measured the EMG of the flexor carpi radialis muscle. And we exercised at 40% of our maximum voluntary contraction force until we were no longer able to sustain that force, so what we'd call volitional exhaustion. We measured a group of people, and we, rather than just looking at one individual, we're going to look at the any kind of systematic changes between the means at different parts or different portions of that trial. In terms of organising the data into different portions, what I've done is organised it into what I'd call into 10% bins. So obviously everybody who does it is going to last a slightly different amount of time. Some people might be able to hold it for 60 seconds, 120 seconds, 180 seconds, or so on and so on. So it's all going to be a bit of a mess, very difficult to do comparisons between individuals at specific time points. So what we've done is just organised it into percentages of total trial duration. So for those who only lasted 60 seconds, they're going to be 10 6-second bins. For those who lasted 2 minutes, it's going to be 10 12-second bins. For those who lasted 3 minutes, it's going to be 10 18-second bins, and so on and so on. Okay, so the way I've organised the data, I've got the category labels, or each condition label in row 1, so 10% of the trial, 20%, 30%, etc. And then I've got the participant identification, or participant name, or participant ID in column A. First thing I'll probably do is calculate some means for each condition. So just a reminder of how you do that using the functions in Excel, which I'm sure you remember, but equals average, open bracket, and then just select all of that data for the first condition, close brackets, and press enter, and equals STDEV for the standard deviation, and then again in brackets just select all of that data. So call that mean, we'll call that one standard deviation, and finally I want to calculate the standard error of the mean. Now there's no actual kind of function in Excel for standard error of the mean, but all it is the standard deviation divided by the square root of the number of people who took part in the experiment. So in this case, the square root of 10. Okay, I'm going to drag those across. So I've got that data for each condition. I want to make it red so you can see what it is we're looking at, and I'll do the same with the labels. And I'm going to just change that so it's just down to 2 decimal places. So to do that, format cells, and just change the type of cell to a number, 2 decimal places, and click OK. And it's just a bit cleaner. I think sometimes when you look at a data sheet, and it's got big long numbers, it can be a little bit daunting. I think it's much easier, much nicer to look at smaller ones like this. So the next thing I'll do is just create a little graph, because I probably want to eyeball the data a little bit, see what it looks like. So insert, I'm going to highlight the data, the mean data, just insert a line graph, and there's my line graph. I'm just going to delete that chart title because I don't want a title there. And while I've got the graph open, actually, we could probably just do a little bit of editing, so we can look at some of the editing options that we've got in Excel. So if you go to add chart element, quite important to have axes, of course, on my graph. So add a vertical axis title, and I'm going to call that one the median power frequency. Okay, and then the data on the bottom here, you can see it's just 1 to 10 for time. I could probably do with getting my percentage bins in there. So again, I'll add a primary horizontal label. I'll call it, just if I can highlight it, I'll call it percent of trial duration, and just include the label. Okay, and then I want to just change this to these 10%, 20%, and so on and so on. So if I just right click on that and use the select data tab, I can select this horizontal category axis label, and for select data source, I'm just going to grab my labels from up the top here where I've got the percentages written in, and that's a little bit tidier now. I've got my percentage bins along the bottom, so percent of trial duration. It's a little bit clearer now what it is that we're looking at. Final thing we want to add is probably some standard deviation bars. So if I just click on the line and again add a chart element, these are going to be error bars. Now, although we said we're going to add a standard deviation bar, I'm actually going to select more error bar options and ignore the standard deviation one. So for the standard deviation, I'm going to select a custom value, make sure the direction is both. I'm going to specify the value, and then for the positive value, I'm going to select my standard deviation that I've calculated there, and then for the negative value I'm going to do exactly the same, because remember that the standard deviation is the variance around the mean, so it's both positive and negative. So then I click OK, and it will show my standard deviations on that graph. So my graph's pretty much finished there, looks a bit nicer. I can kind of eyeball what's going on with the data. What I might want to do is just zoom in on it a little bit. You'll notice there's nothing really going on between 50 and 100, or 60 and 100. So I'll just leave a little bit of space either side. I'll go format major grid lines. No, I won't. I'll do format axis, and then I'll just put the minimum bound at 50, and I'll put the maximum at 110, and then it just kind of zooms in a little bit for me. I can close that down, and there's a nice clear graph. So what you can see on my graph is that there's nothing really happening between 0 and 60%. It doesn't and even 70, I don't really know if 70 is any different than baseline. It doesn't look too different to 40 or 50%, but it may be different to 10%. But actually, once you got to like 80, 90 and 100%, you can start to see some real differences. You start to see a real drop in the frequency of those action potentials, the median power frequency of those action potentials. But that's just eyeballing it, and it's more important for me to do a proper statistical analysis. So in order to do that, I'm going to use the data analysis tool pack in Excel, and as a reminder, the data I'm going to run is a repeated measures ANOVA, 10 repeated measures. So go to data. You should have the data analysis tool pack there. If you don't, you need to add it in the Excel options. So data analysis tool pack, and then the repeated measures ANOVA in Excel is called the ANOVA 2-factor without replication. So select that one and then click OK, and then you can put your input range in, and you check your labels, all the rest of it. So my input range, just as a reminder, is going to be all of my data, including my labels, so including my axis labels and my participant ID numbers. Make sure you've got label, because I've included those labels. Make sure you put labels in and just select somewhere to put that data. So I've gone for A17, just where it's out of the way. It's not going to go over any other data in your computer or anything. Click OK, and it'll run the ANOVA for you. Popped up another box, but close that down. Okay, so this first little bit, so here's the result of my ANOVA. Now this first bit that I'm highlighting at the minute isn't really something that you need to worry about at the minute, not something really you need to look at. What is important is the bottom box, which is the result of the statistical test. And in particular, it's the columns row, which I'll highlight yellow, and just that little error, degrees of freedom for error as well. So you're interested really in the degrees of freedom, the F ratio and the P value. Now you can see the P value there is like nonsense, 4.709 E minus 24, and all that means is that there's just too many decimal places. So you just need to format the cell. So again, if I'm clicked on that cell, if I do format cell and change it from general to number, now if I do enough decimal places, so if I do like 30 decimal places, you'll actually see just here, I've got like 0. and then like 24 decimals and then 4709. So it's a tiny decimal, tiny fraction of a number. I don't report a p-value beyond really 2 decimal places, so I would just write less than 0.01, or because it's so small I could do less than 0.001, but I wouldn't go any further than that with the decimals. I'll just change that back and do 3 decimal places. Okay, so the way I would write that would be as follows. There was a significant, or there is a significant main effect of time for median power frequency, and then put the statistical results in. F981 equals 34.28, and then P is less than 0.001, close brackets. Okay, so I know I've got a significant main effect because P is less than 0.05. In terms of how I would write this, F9.81, if you go format cells, I would subscript the degrees of freedom and the degrees of freedom for error. And obviously the 34.28 is the value of F, and the P is less than 0.0001 is the P value. So yeah, because P is less than 0.05, I know I've got a significant main effect. So the next thing I need to do now, I know that somewhere in that model is a difference, but I need to find out exactly where that difference or those differences lie. So are they between 10 and 20%, between 10 and 30%, 10 and 40, and so on and so on and so on. So in order to do that, I need to do some post hoc tests. And the first step is to create a new table. So it's going to be like 20% minus 10%, 30% minus 10%, 40% minus 10%. So you can see I'm using 10% as like an anchor. I'm comparing everything to 10%. 70% minus 10%, 80% minus 10%, nearly there. And finally 100% minus 10%. Okay, and then I can put my participant information in row A, 10 participants. So if I go up, just then put that data in. So what was the first one? It was 20 minus 10 for participant 1. And then I can just drag that down. So it'll repeat that calculation for each participant. I then kind of want to drag that across, but if I just drag it as it is at the moment, it's going to do like D2 minus C2, E2 minus D2, and so on and so on. Whereas I want to anchor that B2, I don't want that to change. So all I'm going to do to fix that is just put some $signs around the B. And this will take a little moment, but it's worth doing because it certainly beats typing in all of those equations again. So the $signs just go around the B. Okay, and then just kind of drag that along all the way to 100. And if I click on these, you can see now in that 100 minus 10, I've got K minus B, row K minus B. For 90%, I've got row J minus B, and so on and so on. So that's worked. Next thing I want to do is just calculate the mean and standard deviations of those data. So actually, I can just copy those ones from up there and put them back in here. Obviously, because there's a row beneath that I've left blank, row 12 up the top. I also need to leave a row blank down here, otherwise it's going to be off. But I can just check that I've got the right data just by clicking on the equation bar, the function bar, and just checking I've got the right data. And if I do the same for standard deviation, you can see I've got all my data in there, so it's the right type of thing. I'm just going to change the names of these kind of labels to mean difference and standard deviation difference. And then I'm also going to calculate standard error of mean difference. Now, standard error of mean difference is a little bit more difficult than calculating the standard error of the mean. It's not really difficult, but you take the square root of the combined standard error of the means for both of the columns that you're working with at the minute. So I'm working with the 20% column and the 10% column. So I'm going to do equals square root and then open bracket, and then it's the sum of the standard error of the mean for the 10% trial and for the 20% trial. Okay, and then click enter. And again, I want to drag those across, but I want to anchor that B because it's always the 10% trial. So again, just put the dollars around the B before I drag it, and I can just drag that across. So that's my standard error of mean difference. Okay, so the next thing I need to do is work out my kind of confidence factor that I add and subtract from the mean difference. Now you'll remember when we just got two samples, we do a 95% confidence interval with an alpha of 0.05. However, because we've got multiple comparisons, we can't do that because there's just more of a likelihood that we'll get like a random difference between two columns. So if there's just two columns, it's not that likely that they're just by chance they're going to be different from each other. But if I've got like 100 columns, the odds are one of the columns is going to be different from another one in that whole thing. So I've got to kind of I've got to adjust my confidence level to reflect that. And the way I do that, I'm going to just make a little table up here. I'm going to write alpha in. So we know that alpha is normally 0.05. I'm going to have a corrected alpha, and I know that that's going to be right. So what I do with that one is I divide my alpha, my normal alpha 0.05, by the number of comparisons that I'm performing. So here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 comparisons, right? So equals my normal alpha divided by 9. So I get like 0.0055555555. And then I want degrees of freedom is going to be 9. So that's the number of people who took part minus 1. And then I'm going to use the Microsoft Excel's inverse T function to calculate my multiplication factor. So equals TINV, open bracket, probability is my corrected alpha, and degrees of freedom is obviously degrees of freedom. So 3.62 is my multiplication factor. So normally you would, if it was just 2 samples, you would be multiplying that standard error of mean difference by 1.96. We're going to multiply it by 3.6, just to reflect the fact that we've got multiple comparisons. So I'll just call this column something like confidence level, and it's going to be equals the standard error of mean difference multiplied by this new multiplication factor TIMV that I've got up there. Click OK. So it's about 5 for the first one, and then again I want to drag that across. So I'll work it out for each of those columns, but again just remember that as I drag it across, it's going to drag that N57 over to like OPQRS, which have obviously got no data in. So again, just put some $signs around the N, and then when you drag it across, it'll just kind of stay still. Right, now I can calculate my upper and lower confidence levels. Upper and lower confidence intervals. And I'm sure you remember from last year, to do that, I just do the mean difference, add the confidence level for the upper, and it's the mean difference minus the confidence level for the lower. So for that first one, the difference between 10 and 20, for some people median power frequency will go up to 5, greater than it was at 10%. For others it'll go down to about 5 less than it was, but there's no real systematic effect either way. Some people are going up, some people are going down, so there's nothing there. If we drag this across, we want to look for some systematic effects. Before I do so, I'm going to just make all of this, I'm just going to format all these cells. So I'll format cells and just make them 2 decimal places in number. Just a little bit easier to deal with than loads of big decimal places. I'll make it all red as well, so it's clear that this is information I've calculated. And what you can see is that of the data I'm highlighting now, you can see that the upper and the lower pass through 0. So for example, at even at D, you know, some people are up to like 11, nearly 12 down, not from the way on baseline, but some people are actually up by up to 0.95. Same at 50%, some people are up, some people are down. Same at 60%, some are positive, some are negative. So those data pass through 0, so there's no systematic effects. But if you look at 70, 80, 90 and 100%, you see that there's actually some systematic effects. So both the upper and the lower are negative, so the direction of the change in the mean from baseline is systematic. So I can write that up, and I'm going to write it in row 52, just underneath. Or if not, I'll write it in row 51, just after where I've finished my previous statistical sentence. And all I'm going to write is that median power frequency, MPF, so median power frequency is lower at 70%, and then I'm going to put the upper and lower values in, which are -2 to -14 I'll just do 2 to 14 because I've said lower, so I don't have to state the minus. So 70%, 80%, open bracket, and that one's 9 to 21. I'm just rounding these up to the nearest whole number. 90%, open bracket, that one's 19 to 31. And 100%, and that one's 22 to 35. And that is compared with at 10% of the trial duration. Spelling. Right. So the data I've just put in is this data for the 70%, 80%, 90%, and 100%. And that is the result of my statistical test, all written up, and I've created my graph and everything. So that's your repeated measures ANOVA done. Simple, I'm sure. So I think it was about half an hour. So good, well done if you've watched me right through to the end. But have a go yourself, follow it through, try and do those calculations yourself. Good luck with it. I'm sure you can ask me questions if there's anything you're not sure about, and I'll put this analysed spreadsheet on Blackboard as well, so that you can go and have a look at. So exactly as it is, you can just go and have a look at it. And yeah, so use your own data and do exactly the same. Okay, I'll see you in the lecture.